Hello everyone. Here we are interested in getting the equation of the average DC load voltage in case of half wave rectifier. We have derived the equation for the current for the same circuit previously. Now what we are interested in deriving the equation for the voltage. Now first of all, the circuit we know now. I will not repeat the working. Only one thing that we want to recall is that we already now know that the value of DC current, that is IDC, is given by Im by pi, that we already derived. Okay. Now here, before we go for the value of VDC, that is average DC load voltage, we have to get one equation for Im, which we normally use for calculation in case of the numericals. So here is the circuit, and we know that the current is flowing in this path, where we know RL is the resistance, we call it as a load resistance. This is the diode, and the current is flowing like this. The equation for this current is called as the Im, which is flowing in this direction. Now applying KVL, we can get the equation for the current flowing is equal to Vm divided by resistance. So here we are having three resistance actually, Rf plus Rs plus RL. Now what is Vm? Vm is nothing but the voltage which will appear across the secondary. What is Rf? Rf is the resistance of this diode, forward resistance. Rs is the resistance of the secondary winding. Here is the Rs we are having, and RL you all are knowing. Once again, what is Rf? Rf is the diode resistance. Actually, this is the diode forward resistance. Then what is Rs? Rs is the resistance of the secondary winding. Resistance of secondary winding. And RL is already known, that it is nothing but the load resistance. Now we can have our required equation, which is nothing but the average load voltage. It will be given by EDC is equal to IDC multiplied by value of this load resistance RL. And now we can put the value of IDC is equal to Im by pi, this value. So IDC is nothing but the Im by pi multiplied by resistance RL. Okay, but now we have derived, or we have another equation of Im. This equation I have to put here. So if I put this equation here, I will be getting EDC is equal to Vm divided by Rf plus Rs plus RL multiplied by load resistance RL. So this is the equation we have to use here. One thing is remaining, it should be multiplied by pi, okay, because this is Im by pi and this is the equation for Im. So it is Vm divided by Rf plus Rs plus RL multiplied by pi, and here it is RL as it is. Okay. Now another thing is that normally the resistance of this winding and this resistance is very small, because Rf is the forward diode resistance, and when the diode conducts, it normally we say it is acting as a closed switch. So normally Rf is very small and Rs, both are very small, and that's why we can neglect them. So if we neglect these two terms, then we are remaining with only RL. We are neglecting Rf and Rs because they are very small. And if we do this thing, we are remaining with the final equation of EDC, which is normally equal to Vm by pi, because here it remains RL only. This RL will get cancelled, and that's why we are remaining Vm by pi. So that is the final equation which we can have for the average value of DC voltage.